Your modern Ford came straight off the assembly line, programmed to slowly destroy its own mechanical components in the name of government emissions compliance and slick showroom marketing. Most owners drive off the dealership lot fully believing that every default setting on their dashboard and every factory calibration in their engine control module was engineered to make their vehicle last longer. The reality inside my repair bay tells a completely different, brutal story. Today, I'm exposing 5 factory settings and built-in features that are quietly grinding your engine and transmission to dust without you ever knowing it. Setting number 3 has sent more EcoBoost engines to an early grave than almost any manufacturing defect I have seen in 15 years on the shop floor. And setting number 1 is so deceptive that millions of Ford owners actually think it is a beneficial feature designed to save them money at the pump, when in reality, it is doing the exact opposite while cooking internal bearings and starving critical valve train parts of lubrication. Let's get into it. Setting number 5. The Factory Auto Start-Stop Default Calibration. Ford markets this feature as a seamless, eco-friendly innovation designed to reduce idle emissions and cut down on fuel consumption during city driving. Every single time you bring your truck or SUV to a complete stop at a red light or a stop sign, the powertrain control module cuts fuel and ignition, shutting the engine down instantly. The moment your foot lifts off the brake pedal, a heavy-duty starter motor re-engages the flywheel and fires the engine back up in milliseconds. On paper, it sounds like modern engineering brilliance, but here's what Ford does not tell you about the mechanical physics happening inside your engine block during those split seconds. Engines rely on a physical phenomenon called hydrodynamic lubrication. When your engine is running at idle, the oil pump generates constant hydraulic pressure, forcing a microscopic film of engine oil between rotating steel journals and soft aluminum lead bearing shells. Under normal operation, your crankshaft literally floats on a pressurized cushion of oil roughly 0.0015 inches thick, meaning metal never actually touches metal. The moment auto start-stop kills your engine at a traffic light, that hydraulic oil pressure drops to exactly 0 psi in less than 2 seconds. Without oil pressure holding that cushion intact, the heavy steel crankshaft settles down directly onto the main and connecting rod bearing surfaces. When the traffic light turns green and the system restarts the engine, those crank journals rotate against dry bearing surfaces for several critical revolutions before the mechanical oil pump can prime the system and build pressure back up to safe operating levels. This is known in mechanical engineering as a boundary lubrication event, and it is where roughly 80% of all engine wear occurs over the vehicle's lifespan. In a traditional vehicle without auto start-stop, an engine might experience around 30,000 to 50,000 cold and warm start cycles over a 150,000-mile lifetime. With auto start-stop permanently enabled in default factory mode, that exact same engine is subjected to over 300,000 start cycles under identical mileage conditions. Even though Ford utilizes hardened polymer coatings on modern main bearings, those microcontacts accumulate over time. I have personally torn down 3.5-liter and 2.7-liter EcoBoost engines with under 80,000 miles where the polymer bearing overlays were completely scrubbed off, exposing raw copper substrate and dumping microscopic metal particulates directly into the oil pan to circulate through the oiling system. You are trading thousands of dollars in premature engine bearing wear to save a fraction of a gallon of gasoline per tank. The fix for setting number 5 requires no tools and costs $0. Get into the habit of pressing the physical Auto Start-Stop Disable button on your center console every single time you start your vehicle. If you do not want to press the button every time you step into the cab, you can install an inexpensive plug-and-play Auto Start-Stop Eliminator module behind the dash switch in 20 minutes, or plug a scanner into your OBD2 port and permanently disable the start-stop feature in the body control module settings using 4Scan software. Eliminating those constant zero-pressure restarts is the single easiest way to protect your lower engine bearings from dry boundary wear. Setting number 4 is a factory calibration that Ford markets as a hassle-free convenience feature, the 10,000-mile or 1-year Intelligent Oil Life Monitor default interval. When you purchase a new Ford, the owner's manual and dashboard maintenance screen actively encourage you to run your engine oil up to 10,000 miles between service intervals under normal driving conditions. The manufacturer advertises this extended interval to claim a lower projected cost of ownership to fleet managers and prospective buyers, while helping their corporate environmental scores. Here is the mechanical reality that Ford engineers know, but the marketing team ignores. Modern EcoBoost engines utilize direct fuel injection coupled with high-boost turbocharging. Unlike older engines where fuel was sprayed into the intake manifold to mix thoroughly with incoming air, direct injectors spray gasoline straight into the combustion chamber at pressures exceeding 2,900 pounds per square inch. During normal operation, and especially during short city trips, cold starts, and heavy throttle acceleration, a portion of that high-pressure atomized fuel bypasses the piston rings and washes down the cylinder walls into the oil pan below. This process causes severe fuel dilution. By the time an EcoBoost engine reaches 4,000 to 5,000 miles on an oil change, it is common to find 3 to 5% raw gasoline mixed into the engine oil. Gasoline is a harsh solvent, not a lubricant. As fuel dilution increases, it rapidly breaks down the viscosity of your motor oil, degrading a high-quality 5W30 synthetic down to the viscosity equivalent of a watery 0W16 or lower. At the same time, high combustion temperatures and turbocharger heat shearing break down the anti-wear additive packages, specifically zinc and phosphorus compounds, while suspended soot from direct injection combustion turns the oil into an abrasive liquid grinding compound. When you push that degraded, fuel-diluted oil past 5,000 miles toward the factory-recommended 10,000-mile mark, critical components begin starving for protection. The most vulnerable parts in a modern Ford engine are the variable camshaft timing, or VCT phasers, and the turbocharger center housing rotating assemblies. The VCT phasers rely on precise hydraulic oil pressure routed through tiny oil passages measuring less than 0.040 inches in diameter. As dirty, diluted oil shears under extreme heat, sludge and varnish form inside these microscopic passages, causing the VCT solenoids to stick and the phaser locking pins to hammer themselves to pieces on every cold start. That cold start rattling noise that plagues thousands of 3.5-liter EcoBoost owners is directly linked to extended oil change intervals. Furthermore, turbochargers spin at speeds exceeding 150,000 revolutions per minute while operating at temperatures above 1,200 degrees Fahrenheit. Thin, fuel-diluted oil cannot maintain a stable oil film across the floating journal bearings inside the turbo housing, resulting in coked oil lines, shaft play, and catastrophic turbocharger bearing failure. I have pulled oil samples from trucks following the factory 10,000-mile monitor setting that showed severe viscosity loss, heavy soot loading, and elevated iron and copper wear metal numbers indicative of active timing chain stretch and camshaft wear. Meanwhile, trucks whose owners ignored the factory monitor and changed their oil every 4,000 to 5,000 miles routinely crossed 200,000 miles on original VCT phasers, original timing chains, and original factory turbochargers. The solution for setting number 4 is straightforward. Completely ignore the percentage number displayed on your dashboard Intelligent Oil Life Monitor. If you drive a turbocharged EcoBoost engine, change your oil and OEM filter every 4,000 to 5,000 miles or 6 months, whichever comes first. If you drive a naturally aspirated 5.0-liter Coyote V8 or 3.3-liter V6, do not exceed 5,000 to 6,000 miles between changes. Spending an extra $50 on an additional oil change twice a year is the cheapest insurance policy you can buy against a $4,000 VCT timing job or a $3,000 turbocharger replacement. Now that we have exposed how factory start-stop settings and realistic oil life monitors are actively compromising your lower engine bearings and variable timing components, we need to move directly into the mechanical heart of your Ford's engine bay. Settings 3 and 2 involve deeply embedded powertrain logic and factory hardware choices that quietly elevate internal heat and mechanical stress past the breaking point during everyday driving. Setting number 3. The factory EcoBoost high gear lugging and transmission shift logic calibration. Ford programs its Select Shift and 10R 8010 speed automatic transmissions with extremely aggressive upshift schedules designed to satisfy EPA fuel economy testing procedures. Under normal acceleration, the powertrain control module commands rapid upshifts, climbing into 8th, 9th, or 10th gear as fast as humanly possible to drop engine RPMs down into the 1,100 to 1,300 range. Ford advertises this calibration as a smooth, quiet, fuel-saving strategy that keeps the engine operating in its low RPM efficiency sweet spot. Here's the destructive reality of what actually happens when you ask an engine to accelerate or maintain speed at ultra-low RPMs under load, a condition technicians call high-load engine lugging. In a turbocharged, direct-injected EcoBoost engine, pressing the accelerator pedal while the transmission is locked in a top gear at 1,200 revolutions per minute causes the engine control unit to instantly ramp up turbocharger boost pressure to maintain vehicle speed without downshifting. You have full boost pressure, often 15 to 20 pounds per square inch, building inside the combustion chambers while the engine crankshaft is spinning at an extremely low velocity. This combination creates a phenomenon known as low-speed pre-ignition, or LSPI. Because the air-fuel mixture is under massive cylinder pressure at low RPMs, microscopic droplets of engine oil or hot carbon deposits on the piston crowns ignite the incoming fuel charge prematurely, long before the spark plug fires. This creates an uncontrolled, violent combustion spike while the piston is still traveling upward on its compression stroke. The internal cylinder pressures during an LSPI event do not just rise gradually, they spike to over 1,500 psi in a fraction of a millisecond. That violent shock wave hammers down directly onto the piston crown, forcing the piston skirt into the cylinder wall with immense side load forces and hammering the wrist pin and connecting rod bearings. In my shop, setting number 3 has sent more EcoBoost engines to the machine shop than almost any other single condition. I have pulled heads off 3.5-liter and 2.7-liter EcoBoost engines with under 70,000 miles to find broken top piston ring lands, cracked piston skirts, and severely scored cylinder walls, all classic textbook signatures of sustained low-speed pre-ignition caused by factory transmission shift logic, forcing the engine to lug under boost. Beyond the catastrophic threat of LSPI, lugging an engine starves critical valve train components of optimal oil flow. Remember, mechanical oil pumps are gear-driven directly off the crankshaft. At 1,200 revolutions per minute under maximum boost pressure, your oil pump is turning at its lower speed threshold, delivering significantly lower volume and pressure through the block than it would at 2,200 revolutions per minute, right when internal combustion forces on the rod bearings and wrist pins are at their highest. You are subjecting the engine to maximum stress at minimum oil volume. The fix for setting number 3 is simple, immediate, and requires no aftermarket tuning. Stop allowing your transmission to lug your engine in top gears when accelerating or climbing mild grades. When you are driving in hilly terrain, carrying heavy cargo, or operating in stop-and-go traffic, manually switch your drive mode selector from normal to tow/haul or sport mode. These factory drive modes alter the shift calibration, holding gears longer, keeping engine RPMs safely above 1,800 to 2,000 RPMs, where the oil pump delivers maximum flow and where boost builds harmoniously with crankshaft velocity rather than hammering against a slow-moving piston. If you are cruising on the highway in normal mode and need to pass or climb a grade, use the toggle switch on your shifter or paddle shifters to manually lock out 9th and 10th gears before stepping on the throttle. Keeping the engine out of low RPM boost lugging eliminates the physical conditions required for LSPI to occur. Setting number 2. The factory active grille shutter calibration. Paired with high engine operating temperature set points, Ford installs motorized plastic louvers directly behind the front grille on nearly every modern F150, Explorer, and Super Duty. The manufacturer claims these active grille shutters optimize vehicle aerodynamics by closing at highway speeds to reduce drag, while managing engine warm-up times to reduce cold start tailpipe emissions. The dashboard temperature gauge is intentionally programmed with a wide, dead band, remaining pinned dead center in the middle of the normal range, whether your engine coolant is running at a safe 195 degrees or spiking to a dangerously hot 235 degrees Fahrenheit. Here is the engineering reality that Ford does not display on your instrument cluster. To burn off unburned hydrocarbons and meet stringent tailpipe emissions standards, modern Ford engine computers are programmed to keep engine coolant temperatures running exceptionally hot during normal operation. frequently targeting baseline coolant temperatures between 215 and 225 degrees Fahrenheit. To maintain these elevated thermal profiles and cut aerodynamic drag, the powertrain control module commands the active grille shutters to stay completely closed or only partially open during steady-state highway driving, blocking direct airflow to the radiator, air-to-air intercooler, and auxiliary transmission cooler. Heat is the single greatest enemy of rubber seals, synthetic lubricants, electrical connectors, and metallic components. Operating an engine consistently at 220 to 230 degrees Fahrenheit drastically accelerates the thermal oxidation of every fluid in your vehicle. At these elevated temperatures, automatic transmission fluid inside the 10R80 transmission begins to oxidize and lose its friction-modifying properties at double the normal rate, leading to harsh gear engagement, sticking valve body solenoids, and premature wear on internal clutch packs. For EcoBoost owners, setting number 2 creates a secondary thermal disaster: intercooler heat soak. When active grille shutters close off airflow to the front-mounted intercooler at highway speeds, the compressed air coming out of the turbochargers enters the intake manifold at extremely high temperatures, often exceeding 140 to 160 degrees Fahrenheit intake air temperature. Hot intake air contains significantly less oxygen density and drastically lowers the engine's threshold for spark knock and detonation. The engine computer responds by pulling timing and dumping excess raw fuel into the cylinders to cool the combustion chambers, which worsens fuel economy, accelerates carbon accumulation on the intake valves, and bakes the plastic engine components, such as the intake manifold, coolant crossover pipes, and valve covers, until they turn brittle and crack, leaking fluid into the valley of the engine block. I have personally inspected engine bays where active grille shutter actuators failed in the closed position without throwing a hard check engine light, silently cooking the engine oil and transmission fluid for tens of thousands of miles, while the owner remained completely oblivious because the factory dashboard temperature gauge was calibrated to stay sitting comfortably in the middle. The fix for setting number 2 gives your cooling system back its ability to breathe. Inspect your active grille shutter system regularly to verify that the louvers move freely and are not jammed with road debris or stuck shut by a failing actuator motor. If you frequently tow heavy loads, drive in extreme summer heat, or want to permanently reduce underhood thermal stress, you can disconnect the electrical harness to the grille shutter motor when the shutters are in the fully open position, or remove the individual shutter blades entirely while leaving the actuator plugged in, so the computer does not trigger a soft diagnostic code. For a complete solution, installing a cooler 180-degree low-temperature thermostat paired with custom computer tuning allows your cooling system to run at a true, sustained 190 to 195 degrees Fahrenheit, preserving your transmission fluid, protecting your plastic engine components from thermal degradation, and ensuring your intercooler actually receives the ambient air volume required to keep intake temperatures safe. We have covered 4 factory calibrations that are quietly wearing down your bearings, breaking your pistons, and baking your cooling system. But setting number 1 is in a league of its own. It is the single most deceptive feature engineered into modern Ford powertrains. A factory calibration so clever that millions of owners actively praise it for saving them fuel, while it silently starves the upper engine valve train of vital oil pressure and grinds critical internal components to dust. Setting number 1, the variable displacement oil pump factory calibration paired with ultra-low viscosity engine oil specs. On almost every modern Ford powertrain, from the 2.7-liter and 3.5-liter EcoBoost engines to the 5.0-liter Coyote V8, Ford replaced traditional fixed displacement mechanical oil pumps with electronically controlled variable displacement vane oil pumps. The manufacturer markets this system as an advanced efficiency feature designed to reduce mechanical parasitic drag on the crankshaft, claiming it improves overall fuel economy by only pumping the exact volume of oil the engine requires at any given millisecond. Here is the mechanical nightmare happening hidden inside your engine block. Traditional oil pumps are hard-geared to pump more oil and build higher pressure as engine RPM rises, ensuring a massive safety margin of lubrication at all times. The electronic variable displacement oil pump, however, is controlled directly by the engine computer using a solenoid that physically alters the internal displacement of the pump. To squeak out microscopic fractions of a mile per gallon during federal fuel economy testing, Ford calibrates the engine computer to force the oil pump into its low-pressure stage for as long as humanly possible during normal driving. When you are cruising down the highway or sitting at light throttle, the computer deliberately commands the oil pump to restrict output, dropping system oil pressure down to a razor-thin 15 to 20 psi, even at highway speeds. Ford considers this low pressure sufficient to keep the main bearings from failing immediately. But sufficient for emissions testing is light years away from what is required to protect high-stress overhead valve train components over a 200,000-mile lifetime. To make matters infinitely worse, Ford pairs this low-pressure oil pump calibration with an ultra-thin factory oil viscosity specification, often 5W20 or even 0W20. Ultra-thin oil flows easily, but it offers minimal film strength under high heat and heavy mechanical shear. When you combine an ultra-thin oil with a computer calibration that deliberately caps oil pressure at 15 pounds per square inch, the absolute top of your engine becomes a lubrication desert. The components that suffer first and worst are the overhead camshaft journals, the hydraulic roller finger followers, and the variable camshaft timing phasers located at the very highest point of the oiling circuit. These components rely on a robust volume of pressurized oil to cushion the constant, violent hammering of the valve train as the camshaft lobes wipe across the roller followers thousands of times per minute. At 15 pounds per square inch on thin oil, that protective oil film breaks down completely under thermal load. In my shop, I have torn down dozens of 5.0-liter Coyote V8s and EcoBoost engines with under 100,000 miles, where the owners strictly followed factory maintenance schedules and ran factory-recommended oil weights. What I find inside is horrifying. Camshaft lobes galled and pitted, roller finger bearings seized and eating into the cam journals, and metal shavings packed into the VCT solenoids. The upper valve train was literally grinding itself to pieces because the factory computer calibration refused to command high oil pressure during everyday light load driving. The owner thinks they are driving a smooth, efficient vehicle, while under the valve covers, metal is wiping against dry metal. And here is the ultimate insult. The variable displacement oil pump itself is often driven by a small, wet rubber belt located inside the oil pan on certain engine configurations. That wet belt sits submerged in hot, fuel-diluted engine oil day after day. As the oil degrades, the chemicals in the fuel and degraded oil break down the rubber compound of the belt. The belt begins to shed rubber teeth and fine fibers directly into the oil pan. Those rubber fragments get sucked straight into the oil pump pickup tube screen, clogging the mesh and starving the variable oil pump of fluid entirely. When that happens, oil pressure drops to absolute zero, causing sudden, catastrophic engine failure with zero advance warning. The fix for setting number 1 requires taking back control of your engine's lubrication system through smarter maintenance choices. First, throw out the factory recommendation for ultra-thin 0W20 or 5W20 engine oil if your vehicle is out of warranty or operating in warm climates. Step up to a high-quality, full-synthetic 5W30 or 0W30 oil that meets Ford's performance specifications. The slightly higher HTHS, high temperature, high shear, viscosity provides a dramatically stronger protective film across camshaft lobes and rod bearings when the factory oil pump is operating in its low-pressure stage. Second, if you are having your vehicle custom-tuned or using flash software like ForScan or an aftermarket tuner, you can recalibrate the PCM logic to command high oil pressure mode full-time, ensuring your valve train receives maximum oil volume at all times, regardless of engine load. Finally, if your engine utilizes an internal wet oil pump belt, ensure you strictly adhere to 4,000-mile oil change intervals to prevent oil degradation from dissolving the belt material into your oil pan. When you look back at all 5 of these factory settings, from auto start-stop and 10,000-mile oil monitors to low RPM lugging calibrations, active grille shutters, and variable displacement oil pumps, a clear pattern emerges. Modern vehicles are not engineered primarily for maximum mechanical longevity. They are engineered to pass government emissions tests, meet corporate fuel economy targets, and survive just long enough to clear the factory warranty period. The manufacturers win when your engine wears out prematurely at 120,000 miles because it forces you back into the showroom to sign a new finance contract. But as an owner who actually pays for these machines, you do not have to accept that built-in obsolescence. By understanding the mechanical reality behind these factory features and making simple, proactive adjustments to your driving habits and maintenance routines, you take the lifespan of your vehicle back into your own hands. If this deep dive gave you actionable knowledge that will save you thousands of dollars in major repair bills, hit the like button right now and subscribe to the channel so you never miss another real-world mechanical breakdown. Drop a comment below and tell me which of these 5 factory settings surprised you the most, or if you have already experienced a failure caused by one of them. Share this video with every Ford owner in your life before they wind up paying for an engine replacement